Hello everyone, I hope you are doing well. So in this video, we are going to discuss the problems A to F of Codeforces Round 891, which was rated for Division 3. So I did not attempt problem D and F during the contest. I did it just after the contest. I don't know why, but I was not able to focus on the problems today. And even though I was very close to the solutions, but I was not able to complete them. And when I saw other solution, then I realized what I was missing and immediately submitted these two problems D and F. So we're just going to start from the first problem and discuss till the F problem and understand their solutions. So let us quickly start with the first problem. Now this particular problem is array coloring, and it says that we have to divide the whole array into two types of colors, right? So basically we have to divide the array into two groups such that the sum of the elements in each group should have the same parity, right? And we have to just tell whether it is possible or not. So basically, if we have been given an array, let's say you have some elements A1, A2, A3, A4 and A5. You have to form two groups such that there is at least one element in each group, right? So let's say you form A1, A3 and A5 in group 1 and A2 and A4 in group 2. So you calculate the sum of both of these values and their parity should be same. Parity means that if this is odd, this should be also odd, and if this is even, the second one should also be even. This is what they are asking, and we just have to tell whether it is possible or not. So the idea for this particular problem is very simple. Let's say you have some x number of even numbers in the first group and y number of even numbers in the second group, right? So no matter how many even numbers are there, the sum will always be even. So let us say that the sum is even, currently even in both of the groups. Now we introduce one odd number, right? So that particular odd number will either have to go to this particular group, second or the first group, right? No matter in which group it goes, let's say it goes into the first group. In that particular case, the total sum of the first group will become odd. And since this is even, the parity will not be seen. So as soon as I introduced one odd number, one of the groups had to change their parity. Now let's say I introduce other odd number. So now there are a total of two odd numbers, right? So now what I can do is I can either insert it into the first group or insert it into the second group. You will realize no matter which operation I perform, the parity will become same for both of the groups. Because if I insert it into the first group, the parity of the first group is already odd. So if I add one more odd number to it, it will become even. And the parity of the second group is already even. So both of them will become same. Otherwise, if I don't do this, if I add the odd number to the second group, the parity of both the groups will become odd, right? And now they will be same. So whenever the number of odd numbers is an even number, that means the answer will always exist. Otherwise, the answer will never exist, right? Because as soon as I add odd number of odd numbers, I know it sounds strange, but if I count the number of odd numbers and that particular count is an odd value, in that particular case, the answer will not exist because one of the group will have an odd parity, right? So let us quickly have a look at the code. So you see what I've done here is I've taken a vector of size n and taken input in the vector. Now I initialize two variables odd and even. So basically this is just going to count the frequency of both the values. If I and 1, I'm traversing to the vector v. If I and 1, then I just increment the value of odd. Otherwise I increment the value of even. So actually this base condition was not required. It is just something I implemented during the contest, but it is not at all required. You can just directly check if the value of or the frequency of odd numbers is odd, then you can print no, otherwise you can always print yes. So this would be the solution to the first problem. Now let us move on to this second problem. So this particular problem was a particularly implementation problem, and it says that we have been given a string s, and in one operation what we can do is we can choose a positive integer k and round the integer x or the given string s to the kth digit. So I'm just going to explain you this particular part quickly, what they are saying, and the goal is to find the maximum number that is possible. So let me explain you this part with the help of some example. So let's say you have these numbers 1, 2, 3, 4 and 5, let's say, right? So let's say this is the number, and if you choose this particular position, what you can do is you can round off relative to this particular position. So when you try to round off, you will have to check this particular digit, right? So if this digit is greater than or equals to 5, then this particular position will get incremented by 1, right? Otherwise there will be no effect to this particular position. Then you will see that that particular position and all the numbers after it should become 0. So when I round it off, this should also become 5, right? And this particular position will become 0. Let me take one more example. So if it is like 1, 2, 3 and let's say 4, 5, 1, 2, 3, right? So now when I choose this particular position and round off according to it, then the final number will become 1, 2, 3, 5 and 0, 0, 0, 0, right? Now there is one more very important thing. Let's say it was like this 1, 2, 3, 9, 9, 9 and then 5, right? Whenever there is a 9 here, so you cannot increment it, right? So what you will do, you will instead move forward and find the first position which is not equals to 9. Now since this position is not equals to 9, you will increment it and mark all of the remaining numbers as 0, right? So this is all you have to do. You just have to implement it, and while implementing it, you will have to maintain a couple of pointers. Now before looking at the code, I'll just try to explain you how we can implement it, and when I show you the code, the implementation will be much more clear to you. So what I'm trying to do is, let's say I had this number 1, 2, 3, 4, 5. I will try to traverse from the back, right? And as soon as I encounter a number which is greater than or equals to 5, then I will check the number to the left of it and find the first number which is not equals to 9, right? So for example, here I was finding the first number not equals to 9, and similarly here I will also find the first number not equals to 9, right? So as soon as I find it, I'll update my number and save the position just right to it somewhere. So I'll be maintaining a variable POS, and this is going to store the position of just right to the last updated variable, right? So if this 4 was updated, I'll save this particular position of 5. Why is it so? Because when I update this, all of the numbers after it should become 0, right? So I'm keeping track of this position so that I know which numbers I need to mark as 0. Similarly, I wanted to update this 3 here, so I'll store this particular position in the variable POS, right? Now when I know this, I'll just keep on going to the left and keep on incrementing the values. Now let us have a look at the code, and the implementation will be much more clear to you. So what you see, what I've done is I've taken a string input and I've initialized the value of n as the size of the string, and I'm starting my index with n minus 1. I've also initialized my POS variable with n, and while my index is greater than minus 1, I'll just check whether this value at the current index is greater than or equals to 5 or not. Now I initialize my next index as ind minus 1. So while this next is greater than minus 1 and s dot next is equals to 9. As long as I am getting 9, I just need to decrement the value of next. Now if my next is equals to minus 1, that means I have exhausted my whole string, and in that particular case I need to add 1 to the front of the string. Why is it so? Let me just give you an example here also. Let's say the string was like this, right? So what will you do if you round off from this particular position? You will see that while finding a number smaller than 9, you will actually reach this particular position. So you will have to mark this as 1 and all of the remaining values will be 0. So it will be like this, right? So that is exactly what I'm doing here. I'm marking POS as 1 and I'm setting S as 1 plus S. And since there will be no operations further, I can just break from here. Otherwise, what I'll do is I'll update my index as next, I'll update my POS as next plus 1, and I just take the value at this particular position, I increment it by 1 and I update the value of S of index, right? And if this value was not greater than or equals to 5, then I can just directly decrement the value of index. I don't have to touch anything. Now I just run a simple for loop from position to size of string, and I can mark all S of I as 0, right? At the end, I can just print my string S, and this would be my final solution. So let us have a look at the third problem. So this particular problem says that we initially had an array of n integers, right? So what Shasha did, he just took all the pairs ai and aj and obtained a new array b of size n into n minus 1 by 2. Now what will be the contents of this new array b? So basically, if the initial array a is like this, what he will do, he will find the minimum of 2, 3, then 2, 5, then 2, 1. So this is basically a1, a2, a1, a3 and a1, a4. Right. So this way he is finding the minimum of all the values and he gets this final array, and the final array will not necessarily be in this particular order, it can be shuffled, right? So here it says that the final array can be shuffled. Now we have to restore the original array A such that it satisfies these constraints on the array B. right? And all the elements in the array A should be from the range minus 10 raised to power 9 to 10 raised to power 9. So this particular problem was just a bit of observation, and let us see how we can solve it. So let us try to form the array. Let's say A1, A2, A3 and A4. Let's say this is the original array, right? And I'm assuming that they are following this particular relation, that A1 is less than A2 and A2 is less than A3, A3 is less than A4, right? So if this is the original array, then minimum of A1 comma A2 will be equals to A1, minimum of A1 comma A3 will be equals to A1 again, and similarly minimum of A1 comma A4 will be equals to A1 again, right? So 3 of the values in my array B is going to be A1, 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 right? Now if I check for A2, then minimum of A2 comma A3 is going to be A2 itself, and minimum of A2 comma A4 is going to be A2 itself. Now minimum of A3 comma A4 is going to be A3. Now you see we have formed all n into n minus 1 by 2 pairs, and the next 3 values are A2 we have 2 times, and then we have A3. So did you observe something in this particular case? If we take the array B and sort it according to the values, then the first 3 values, if the array is of size 4, then the first 3 values will be equals to A1, the next 2 values will be equals to A2, and the next 1 value will be equals to A3. So if the initial array A is of size, let's say n, let's assume any general size, and let's say we have sorted our input array B. So the first n minus 1 values is going to denote the value A1. The next n minus 2 values is going to denote the value A2. The next n minus 3 values is going to denote the array value A3, and so on, right? And you will see that let's say the next n minus 1 values will denote the value of A of n minus 1, right? So what about A of n? You can take it to be any large value like 10 raised to power 9, and it will always work. Why this will always work? In the examples that we see, A4 will never exist, right? So no matter what value of A4 we take, it should always work as long as it is greater than A3, right? So since 10 raised to power 9 is the maximum value, that means it should be greater than A3. That is why 10 raised to power 9 will always work, right? So let us also have a look at the code. So you will see what I've done here is, first of all, I have taken an input integer n, and I have created the size that is equals to n into n minus 1 by 2, and I have taken input in the vector v of size equals to this particular variable. Now I just sort all the values in the vector v. I initialize my answer vector, and I initialize this index with 0 and add with n minus 1. Now I run a while loop. While add is greater than 0, I just push back this v of index into my answer vector, and I'll increment my index with the value of add. And since I want to decrement the value of add next time, that is why I'm going to use post decrement. So what it will do, it will first add n minus 1 to my index, then n minus 2 to my index, then n minus 3, and so on, right? When the value of add becomes 0, that means I can just break out this while loop. Now I can, for the last value, I can just push back 10 raised to power 9, and I can just print all the values in my answer vector. So this would be the solution to the third problem. Now moving on to the fourth problem. So this problem was also fairly simple. This problem states that we have been given 2 arrays A and B, and both of the arrays have index from 1 to n. Now there will exist an edge from U to V if the value of AU minus AV is greater than equals to BU minus BV. Now our task is to find all the strong vertices. What are strong vertices? Strong vertices are those vertices from which there will always exist the path to all the other vertices. So what is the path? If I am saying that there is a path between A and B, that means there should be a sequence of edges between A and B that will help me to go from A to B, right? Now the input will be like this. We will be given 2 arrays of size n, and we have to find the number of strong vertices. Now with a bit of observation, you will see that they are saying that A of, let's say, U minus A of V should be greater than equals to B of U minus B of V. So I can also write it as A of U minus B of U should be greater than equals to A of V minus B of V. That means if I take any index I and j, then the difference between AI minus BI should be greater than equals to AJ minus BJ, for an edge to exist from I to j, right? So if this condition is satisfied, only then an edge from I to j will be considered. So that means I want this value of ai minus pi to be as maximum as possible. So let's say I have these values a1 minus b1 and a2 minus p2 and a3 minus p3 and a4 minus p4. Let's say these values are arranged in non-decreasing order. So let's say this is less than, this is less than, and this is less than equals to. So you will see that this particular value is greater than all the other values, right? So definitely an edge will exist from here to here, then here to here, and then here to here, right? So the last position will always be one of the answers. Now what you will see, an edge will exist from here to here and here to here, but since this is an equal sign, that means an edge will also exist like this, right? So this means I can go to all the other vertices from this particular position as well, right? Now you will see for this particular value, for the vertex 2, I cannot go to this particular position, neither I can go to this particular position. So you will see that I can also not form the answer for this, because from here I cannot go to here. Now with this particular example, we realized that all the positions which have the difference equal to the maximum difference between ai and bi will always be the part of the answers, and all the other values will have to be discarded, right? So this was the only observation in this particular question. Now what you can do is you can just calculate the values of ai minus bi, and for all the indexes which have the values equals to the maximum value of ai minus bi, they will be a part of the answer, right? So let us have a look at the code. So what I've done is, actually I have implemented it in a little complex manner. I'm performing sorting and I'm also maintaining a set, but this is not actually required. You can solve this problem in a much easier manner as well. You just have to check what are all the indexes in which the difference is equal to the maximum difference between ai and ba. So here what I do is I take two vectors a and b, both of size n, and I created a vector of pairs called dx. Now I'm just traversing through all the positions from 0 to less than n, and I'm storing the difference in the first part of my dx vector and storing the index in the second part. Now I just sort all the values of dx. Now I am running a reverse for loop from n minus 1 to greater than minus 1, and if the current value of dx is equals to the last value of dx, that means the current value is equals to the maximum value, then I can insert this particular index in my answer set, right? And since I was taking 0-based indexing here, I have to increment it by 1 here. Otherwise, if it is not equal, then I can just break, because all the other values after it will never be equal, right? Now I can just print the size of my set, and at the end I can just print the elements of the set. So this was all about the D problem. Now let us have a look at this particular problem. So this problem says that we have been given a point with some integer coordinates x1, x2 up to xn, right? Now if we choose some integer s, right, and we construct these types of segments, so sx1, sx2 up to sxn, right? And obviously they are saying that if xi is less than x, then it will look like xi comma s, right? So basically if we take some integer s, we have to form its pair with every integer in the given input array. Now each of these segments will cover some integer coordinates from a to b, and the power of a point p is defined as the number of segments that intersect with point p, right? Now for all the points we have to find the summation of their powers. I know that this question sounds a little bit like complex, but with the help of some diagrams you will realize that this question is actually very easy. So we will actually have to work with different values of s. So for this particular first index, the value of s will be equals to 1, then the value of s will be equals to 4, then the value of s will be equals to 3, and we have to find the answer for all of them one by one, right? So let us understand with this first example only, 1, 4, 3, right? So if I have, let's say 1, 4 and 3, let me just write it in some order. So let me just write it as 1, 3 and 4. So let me just also draw a straight line. So let's say this is my number line. So 1 is here, and let's say 3 is here, and then 4 is here. Now my first range will be from 1 to 3, right? So it will be a range like this, and it will cover 3 points, 1, 2 and 3. So let me just write 3 here. Now my next range can be from 1 to 4. Now it will cover 4 points, 1, 2, 3 and 4 as well. So I can just add 4 to it. Now I can also have a range from 1 to 1 itself. So it will be a range starting from 1 and ending at 1. So it will only cover 1 point and that will add 1 to my answer. So the total value here is 8 and this is the correct answer for s is equals to 1. Now you will realize that this value is nothing, just the distance between these 2 points, right? And since both of the points are included, we can take, let's say if you have 2 points x and y, we'll have to take y minus x plus 1. So this will be the value contributed by some pair x comma y. So it is easy to find the answer for the initial value of 1, right? Now for each of the values, I cannot compute the answer again and again. So what I'll try to do is, I'll try to keep track of the change that happens when I move from one value to the other value, right? So here you will see that, let's say if I was taking s is equals to 1, I was getting my answer equals to 8. Now let us see what happens when I make my s is equals to 3, right? So we'll erase all of this. Now one answer will always remain the same. Now s is equals to 3. And that answer is the range to range itself, right? So if I take the value from 3 to 3, it will be equals to 1. Now the other pair I can have is 1 comma 3, right? Now 1 comma 3 is like this and it will contribute 3 to my answer. Now the other range can be 3 comma 4 and it will contribute 2 to my answer. So if you like write some values like these, so let's say I have a1, a2, a3, a4, a5. Right, A1 was taking ranges like this from A1 to A2, A1 to A3, then A1 to A4, then A1 to A5. Right, if I move to A2, then A1 to A2 will still be there as one range. Right, so this range will not get affected. This is similar to what you have seen here, that when I was taking 1, then 1 to 3 was one of my answers, and again 1 to 3 is one of my answers. Now what about the values after it? Right, so you will see that when I moved from 1 to 3, right, then the distance of my current point with this last point got decremented by this difference. So this difference, right? So let me just show you with an example. So let's say when I made a point from A1 to A5, then the answer was that it was contributing was A5 minus A1 plus 1. Now if I move this point to A2, now my answer till A5 will be A5 minus A2 plus 1. So what is the difference between these two values? It will be equals to A2 minus A1, right? And it will happen for all the points A3, A4 and A5 as well. So what I'll have to do is, the answer will get decremented by the number of points that are after A2 multiplied by A2 minus A1, right? Because this is the difference that is being generated. And the same difference is being generated for all of these points, right? So this value has to be subtracted from my answer. Now the question is, if this value is getting subtracted, is there any new value that is being added as well? Yes, there is a value that is being added, and let us discuss what is it. So let us draw the answer for A2 first. So the ranges will be like this: A1, A2, A2, A3, A2, A4 and A2, A5, right? Now if we move to A3, let's say if you move to A3, and let me just draw again for A3, A1, A2, A3, A4, A5, right? Now the ranges will be A2, A3 and A1, A2 and A3, A4 and A3, A5, right? So these will be the ranges. Now we have talked about what will be the decrement for these particular elements. A2 and A3 still remains the same. You will see that it is remaining the same. But now a new edge has been created between A1 and A3. Right. So let's say A0 was also here. So initially the edge would have been A2 to A0, but now the new edge will be from A0 to A3. Right. So that means this particular distance, that is the distance between A2 and A3, right? So this distance will get added to my answer. And for how many points will this distance get added? For all the points which are less than A2. So if my current index, new updated index is, let's say I, for all the points which are less than or equals to I minus 2 index, that is from this particular position. So that means I can take the difference A3 minus A2 multiplied by I minus 2 and these will be the values that will get added to my answer, right? So we have seen what is the difference that is being made by the elements to the right of the current element, and we have seen what is the difference that has been created by the elements to the left of the current element. And for the two adjacent elements, the answer will not change, because if we were earlier calculating A2, A3, then we are again calculating A2, A3, right? So the answer for adjacent element will not change, but all the elements to the left of it and all the elements to the right of it, for these elements the answer will change. And since we have seen how this answer is changing, we can calculate our final answer. So let me just show you the code and you'll be able to understand it in a much better way. So what I've done is I've taken two vector of pairs. One is v and one is answer. Both is of size n, and I am just running a for loop, taking input in the vector v. So the first value will be the input values and the second value will be the index. Now I'm just sorting all the values of v and I'm just marking the answer of I dot second is equal to v of I dot second. So this is just to preserve the indexes of those array elements. Now initialize my answer with 1. So this answer 1 will be corresponding to the range a comma a itself, right? Now for all the other ranges, what I am doing is I am just adding this particular value to my answer, that is v of I dot first minus v of 0 dot first plus 1. So basically I am calculating the distance of all the other points from the 0th point or the first point, right? Now I am marking my answer of 0 dot first as result. So I am just traversing through all the other values now, and first of all I will find the value of dx, that is the difference between the current value and the previous value. So as I have already discussed, all the values that are after this particular index, that is n minus 1 minus I. So these will be the number of values that are after my current index, and let me just show you how this is n minus I minus 1. So let's say you have a0, a1, a2 and a3. Now you are moving from a1 to a2 and your n value is 4. So n minus 1 will be equals to 3 and 3 minus 2 will be equals to 1. So if you are at index 2, it will denote that there is one element after it, right? So that is why I am decrementing dx into n minus 1 minus I. Now I am incrementing the value of result by dx into I minus 1. So how is it I minus 1? Again, if the value of I is equals to 2, then I subtract 1 from it and the value will be 1. What is 1? 1 is the number of elements to the left of this particular element, and that are these elements, right? So this is the value that I'll have to add to my answer. So I'm just adding it and I'm just marking my answer of I dot first as result. Now I am sorting my answer vector with respect to the indexes, and at the end I can just print the contents of my answer vector. So this was all about this particular problem. Now let us have a look at this final problem of today's discussion. So they say that we have been given an array of n and we have to answer q queries. So each of the queries gives us two integers x and y, and we have to find the number of pairs I and j such that ai plus aj is equals to x and ai into aj is equals to y, right? So this problem required a bit of mathematics, and other than that this problem was very easy as well. So let us have a look at how we can solve this problem. Let's say we have been given the sum as x and the product as y, and let the numbers be a and b, right? So I know that a plus b whole square is equals to a square plus b square plus 2ab. So basically a plus b whole square will be equals to x square is equals to a square plus b square plus 2y, right? And let us say we have the difference a minus b as a square plus b square minus 2ab. So I can put the value of a square plus b square from here. It is equals to, let me write it first, then this value of a square plus b square can be substituted by x square minus 2y minus 2y. So this ab is converted into y because the product is written as y, right? So a square plus b square is equals to x square minus 2y, that has been taken from here, and this 2y was already here. So that means a minus b whole square is equals to x square minus 4y. That is the square of the sum minus 4 times the product, right? So this is equals to a minus b whole square. Now I can find the value of a minus b, and that will be equals to square root of x square minus 4y, right? Now I know the value of a plus b, I know the value of a minus b, then I can find the value of 2a, and if I find the value of 2a, I'll be able to find the value of a, And if I find the value of A, then I'll be able to find the value of B, right? Because I know the sum, I know the value of A, and I can find the value of B. If you understood this step, then this problem will be a cakewalk for you. Otherwise, you will spend most of the time struggling with this problem, right? So now let us define a couple of checks that we need to make sure that this particular problem is solvable. First of all, I'll have to check that the value of x square minus 4y should be greater than equals to 0. Because if it is less than 0, then the square root will never exist. Now let's say this value was greater than 0 and I have also found the square root. Then the square root should be a perfect square root, right? That particular square root cannot be some floating point number. The simple reason being, when I subtract two numbers of integers, then it should also give me another integer, right? It cannot be a floating number. So I just have to check these two things, and then let's say A and B are coming out to be equal, right? Both of the values are equal. Let's say in this particular case, when the sum is equals to 2 and the product is equals to 1, then the value should be 1 comma 1, right? Because the sum is 2 and product is 1. So if both of the values A and B are equal, then the answer will be frequency of A multiplied by frequency of A minus 1 by 2, right? Like this. Why is it like this? For example, if I have 5 number of ones like these, so this one can make pair with these 4 ones, right? Now the second one can make pair with this 3 ones. Now the third one can make pair with this 2 ones, and the last one can make pair with this one, right? So the answer is 4 plus 3 plus 2 plus 1, which is effectively equals to n into n minus 1 by 2, right? So if both of the values are equal, you will have to apply this particular formula. Otherwise, if both of the values are different, you can do fa into fb, right? So this will be your final answer. Now you just had to observe this particular mathematical derivation, and other than that, there was nothing in this particular problem. So let us have a look at the code. So you see what I've done is, I've created a map of frequency and I'm just traversing through the input vector v, and I'm just incrementing the frequency of all the elements. Now I take the input q and I'm going through all the queries. Now there will be two inputs, sum and product. I take input in it, and first of all I'll find the value of difference square, right? So this is not the difference of the elements, this is actually the difference square. So it will be equal to sum into sum minus 4 into product. If this difference square is less than 0, then I can straight away print 0 and I can just continue to the next iteration. Now I can calculate the difference of the elements as square root of difference square value, right? Now if this value difference into difference is not equal to difference square, that means the answer can be 0 and I can just continue. So this statement will ensure that the square root of difference square is actually an integer value and not some floating point number. And how will it check it? Because if the answer is some floating point number, then after being converted into integer, the floating point will drop, and these in this particular equation will not actually satisfy. Now I can find the value of x as sum plus difference divided by 2, right? And I can find the value of y as sum minus x. Now I initialize my answer with 0, and if both of the values are equal, x is equal to y, I just check if it is present in my map f or not. If it is present, then I can find my answer as f of x into f of x minus 1 divided by 2. And otherwise, what I can do is, I can check whether both f and y are present in my map or not. If both of them are present, then I can just form my answer as f of x into f of y. Now I can just print my answer value for this particular iteration, and at the end I can just print a new line. So you might be wondering, why am I checking before just directly performing this operation? What generally happens in a map is, if you do this particular thing f of x, or if you try to check with this particular operation whether x is present or not, it will create a key x in the map and it will initialize its value to 0. So you will still get the correct answer 0, but it will also create a key into the map, and this will lead to unnecessary memory usage, and in some cases it also gives us memory limit exceeded when there are too much unique values of x and y. Right, so that is why it is better to just check first whether this value is present in the map or not. Only if it is present, we are going to check its value. Right, so this is something that you can take care of, and this was all about this particular problem and today's contest. I hope that you guys were able to understand the solutions. If you guys did, then consider dropping a like on this video, and don't forget to share your thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach more number of people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.